Welcome back. This is video 2 for object-oriented snake game, and in the last video I explained all about how to set up the Apple image. So here is the Apple object constructor, and it just takes a pair of coordinates and sets up its image variable and has a draw method for displaying that image variable at the x and y coordinates using this global variable bw, which I defined up here. This is an array of pure randomness. I actually wrote a Python script just to generate all of this randomness, but it's just like ones and zeros in two-dimensional arrays all wrapped up in a third dimension. So like this is a two-dimensional array. It's an array with arrays inside of it. And then this is also inside of the apple seed array, and it's another two-dimensional array. So each of these arrays represents a level, but I got tired of that method, and my Python script wasn't that great, so even after creating these, I had to put them all in and modify them a little bit and delete white space or adjust tabs and whatever. And another thing is that writing out all of this stuff, whether you're doing it or a Python script's doing it, it's going to slow down your program's load time. So a great way of writing games like this is to do things dynamically, and instead of having, it doesn't matter too much where the apples are. The game is still pretty much the same concept. Go out and eat all the apples without killing yourself or running into the walls. And so I included a second way of doing this. Instead of having a static map for the levels, I created a dynamic one, which actually I will backtrack a little bit and keep talking about the static method. So Appleseed is our three-dimensional array. This is going to be a two-dimensional array, but before I decide what to put in the two-dimensional array, I define this function, and it's going to return a two-dimensional array. See, apples list equals gen apples. So the gen apples function does its thing. It goes through these loops and it pushes apple objects into a temporary array, and then it returns the temporary array, so that temporary array goes into the apples list. And that is just a list of apple objects. That's your board data for that particular game. So these apples is another temporary variable which gets the ones and zeros out of the apple seed array. It just looks at what level you're on and extracts one of these two-dimensional arrays from the apple seeds. And then you have these double for loops that go along these apples, which is that two-dimensional list of ones and zeros. If it comes across a 1 at whatever coordinate in the two-dimensional array, then it's going to push apple object into the temp array that gets returned into the apples list. So this terminating parameter, width is 400. Width divided by 40 is like 10. So it's going to loop across 10 different coordinates. But it's like confined to the integers. So I can be like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then when I is the index of these apples, like it doesn't have a problem. There's no possibility of I being a negative number or a floating point number. It's just 0 through 9. So that's great because these apples is a two-dimensional array extracted from the apple seeds. So that was just kind of like, I had to think about it. I had to make sure that like 0 through 9 was the correct coordinates for that first level. And I just did it that way and it didn't break. See, there's 10 coordinates because like my Python script that I wrote to create this little chunk of ones and zeros, I told it to spit out 10 random ones and zeros. Okay, so hopefully you understand the apples list now contains apple objects. Oh, and by the way, they got scaled back out to their actual coordinates. Like if I just put I and j in, then it would draw a whole cluster of apples up in this corner. Actually, they would all be like right in here, 10 pixels by 10 pixel corner for that first level, based on how far along they are in this array. So like that object right there would be 3 pixels along and 0 pixels down. But I scale them back out by multiplying I and j by bw. So 3 becomes 30. So now let's talk about the dynamic version. I don't even need to extract an array from the apple seed because that's the point. We're trying to get rid of that need to have that huge cluster of data at the top of the program that cuts back on load time. Increases load time. So set up a temp array just like we did in the first genapples function. And this function takes a number and you put the number in to control the for loop. So if I say gen apples dynamic 10, then it's going to give me back an array with 10 dynamically generated apple objects. So here I'm setting up a random number between 0 and, well, I think BW actually changes somewhere. It's not a static 40 throughout the game. Because as you progress, like the snake gets smaller, that's because I'm changing the block width variable. So, but if it was 40, then this would be 0 to 360. And I need to stop at 360 because block width, remember in the apples object, determines the dimensions of the image that the apples are drawing. I don't know if I said that right. Moving onward. So I create a random variable, and this little chunk of code right here basically says subtract off any remainders when dividing by block width. So hypothetically, if block width was 40 and I generated 49 right here, then this is going to subtract off 9. If I generate 87, this will subtract off 7. It's just going to reduce my randomly generated x variable into the lattice of allowable coordinates for apple objects, such that when my snake is going along and I test for collisions, because when I wrote that code, I didn't do like the rectangle overlap method. I tested literal coordinates. So it's very important that my apples are on these specific numbers. 40 is good, 41 is not, that kind of thing. And then the same thing for y, and then I just push the apple object that I just calculated using those two random numbers into this array, and then I return that array. So notice, like, I don't call that function right here because right now I'm just setting up the program. This gets called once to set up that very first level, but this just gets set up as a function to get used later on when I detect that the game is over and I've used up all of my nicely generated static levels. So I'm not going to talk about these because I've talked about them in other videos, but essentially I just set up key listeners, and that is used in the snake move function. Is that in here? Update. The snake.update method uses those keys arrays to determine what direction the snake is in. This .dir is part of the snake objects, and it gets initiated as none. And that is why the snake starts out not moving, and then as soon as you click a key, up, down, left, right, he starts moving. This is a list of body part objects which are defined up here, and it's just rectangles with a coordinate. Body part objects, that's pretty much all there is to them. They have a color, a coordinate, a draw method. It just draws a rectangle wherever you tell it. And this is a dynamic list because the body parts are created with a specific location. They don't ever move anywhere, but they get stored in this variable right here. And like right here is an example of how to create them using new body part, and that's that constructor right there, x and y coordinates and a color. That's that simple. And then you just push them into this array. And then later on, I remove things from that array. This is that array that stores all those body parts. And if it's greater than some number, get rid of the 0 element of the array. And that number is initialized as 4, which is why when you start out the game, you see it creating body parts, and then deleting body parts from the end of the array. And when you eat apples, the reason it grows longer is because I'm modifying this variable, which is the limiter on this array. And I didn't skip anything else, so onward into the update function. As I have already mentioned, there is a direction variable, which is just storing a string, down, right, up, left, none. And looking at the key listeners, you decide oh, so when you're playing the game, if you are going up and you click down, it's not going to let you go down. And the reason why is because, so if I click down, it's not just going to check if that listener got triggered, it's also going to check that I'm not traveling up. So that's all these conditionals are. Is just before you switch the direction based on the listener, you need to check the direction that you're already heading in so that you don't double back on yourself. Any other time you double back, like if you loop back, then you're going to kill yourself. But like snakes can't like bend backwards. There's actually a glitch in this program where I think it has something to do with the refresh rate. Like if you do something weird, like I'm pushing down and it's not letting him kill himself. But there is some glitch in the game. I think it actually has to do like if you click right while it's and before like it refreshes and actually turns him right, then you click down like really quickly, right down, then it won't move him right at all. It'll just move him back down, and then some other algorithm down here somewhere will detect, oh, there's a collision from one body part to the other. He's dead.